So we're going to do what's called differential equations. If you end up liking this topic, there's a whole course called differential equations that you can take in college. People abbreviate it diffie-q. Hey, did you do the diffie-q homework? I remember hearing that in college. It's like, so anyway, let me start with this before I really even explain what we're doing. What does dy dx mean? That's perfect. You're all awesome. Now say we're going to go backwards, kind of like you had velocity and you were trying to get back to position. All right, so we would do a what? Like if you want the equation for antiderivative. So what would be your antiderivative for this? It'd be 2x squared, good, plus 3x, and then it would be plus c. But I gave you what's called an initial condition. If you plug in 0, you want to end up with 5. So we're actually going to, instead of plus c, we're going to put plus 5. And that's the answer. In a nutshell, that's what differential equations are. Now they can get a whole lot more sticky than that and complicated and stuff. So I'm going to give you some steps, but that's like basically what it is that we're doing. We're going backwards. If you leave the plus c in there, oh, go ahead and close that. It's called a general solution. Can you just close it? If you leave the plus c in there, it's called a general solution because c can be anything. So it's like an infinite number of answers, if you will. If you get an initial condition, you're finding one answer, and that's called the particular solution. This is really important that you understand the difference. General means plus c is in there. That's infinite answers. Particular solution means there's only one. That's if you have an initial condition. Do you get what I'm saying? One versus infinite. So steps. The first thing that you're going to do is separate the variables. Everything with a y goes to the left. Everything with an x goes to the right. Always, Miss Cole? Yes. What if I want to do it the other way? No. Y goes to the left, x goes to the right. The way you can remember that is your answers at the end should be y equals blah, blah, blah. So y should go to the left, all right? So separate the variables. Then you're going to do the antiderivative and make sure you put plus c. The plus c is so important that occasionally they make that worth a point on the AP exam. And there will be one of these on the free response. And you can get all the points. It's like, I always say this is the part that's like ka-ching, 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 points, 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 because if you just follow the steps, you're going to get it. All right, step 3, you're going to use the initial condition if there is one. If there's not, then you just skip that step. Just don't do that. But if there is one, that's where you plug it in and you find what C is, that one particular answer. And then lastly, you solve for Y, which is just a great big bunch of algebra, which is, in all honesty, where most people get stuck. Okay, because the algebra can get messy. This is very much follow these steps, get your answer. It is very much do this, do this, do this. Here's your answer. Which is why I end with this. If you look up there at the objectives, we don't do the purple stuff. The purple stuff is BC. This is actually what they call Unit 7. I skip that and I come back to it at the end because it's a nice topic to end on. Everyone likes kind of, if you wanted to end with the stuff we just did, no, you like to end on like a happy note, right? So that's why I come back and end with this. All right, so look at this one. You want to get everything of the y on the left side. To do that, you would multiply over the 3y squared. See what I'm saying there? Okay, so 3y squared goes to that side. I'm going to leave the dy there. And then what you're going to do is multiply the dx to the right side. Do you see that there? So it's going to be equals 1 dx. Now, I usually make this a different color so it'll show up on here. You don't have to, but I usually try to make it so that you can see it's the next step. So we did step 1. We separated the variables. Your next step is to do the antiderivative. So I try to make that just like look different. So what have you got? What's your antiderivative for 3y squared? Y cubed equals, and then what's an antiderivative of like just 1? X, good, and then plus C. So is there an initial condition written here? No, so we're going to find the general solution. We're just going to leave plus C in there. It's an infinite number of answers. We're going to skip this step. Just solve for Y. How would you get Y by itself? Your answer is cube root X plus C. Let's do the next one. What would you do to separate the variables? Like, how would you get y to the left side? Yeah, times over the 4y. You get 4y dy equals, yeah, like that stuff, and then multiply over the dx. So that's separating the variables. Then you're going to do the antiderivative. Put your little integrals in there. What's your antiderivative for 4y? 2y squared, you guys are on top of that, equals, now you would want this to be 1/6 x to the 6, but there's already a 3 there. So good, 3/6, which would be 1/2 x to the 6 plus x plus c. The c is so important, again, that sometimes they make that worth a point by itself. Make sure you put that, okay? Or they'll say, no points from then on if you don't put the plus c, like you're out for the rest of the problem. It is so important. Yeah, go ahead.
So if you don't plus c, then so like go.
Yeah, they will stop grading it there and you're out. You'll get what the points so far, which usually it's 1 for separating it and 1 for doing the antiderivatives, but you'd lose the rest because they'll just stop. Make sure you write it. Now this one has an initial condition. Do you see that? We're going to plug in 0 for x. It's always nice when it's 0, but it's not always. All right. And then -2 for y. So if all these x's are 0, then on the right side, you just have c. If you plug in -2 for y, what are you going to get over here? 8. Good. So c is 8. Then what you do is you go back to the step prior, and sometimes I'll put like an arrow there. You don't have to. I'm just like, hey, this is the step you're going back to. You're going to recopy it literally exactly like it looks, but instead of plus c, you're going to write plus 8. And then you're on to the algebra. From here on out, it's algebra. You have to get y by itself. So what would you do to both sides? Now here's the easiest way to do that. Are you looking? And it can be as messy as you want on the free response. You leave it alone. That's the grader's job to sift through that, not your job. It's your job to do it and then walk away. Now, how would you get rid of a squared? Now you have to choose. Now, if it's the general answer in general, you would put plus and minus because that's all the answers. It's an infinite number of them. Thank you for heads nod. Appreciate that. If you want one particular solution, you have to choose, is it positive or is it negative? And it comes back to the y value on your initial condition. Do you see how your output value is negative? That means you need the negative square root, like the negative version of it. So your final answer is going to be y equals negative square root of stuff. Yes. And again, it can be as messy as you want to leave it on the free response. That's the grader's job to sift through that, not yours. You just do the problem and walk away. That's their business to figure out if it's right or not. Yeah, basically that's what you're doing. And I don't have a problem with that because they're equal. So, all right. How would you get the y moved to the left in this one? This one's a little bit harder. You would divide. So you want to write it like this. Do you see what I did there? If you're dividing it over, it would be to the -4th dy. You're going to do the exact same steps. It's just negative, and that throws everybody off. Negatives are hard. It is. All right. Equals, and then what would still be on the right side? Yep. 4x dx. Beautiful. You got that. And so like on the AP exam, you got a point already. You get a point for separating it. There are, and we're going to go over this very thoroughly once we finish the curriculum for the year. There are 30 multiple choice that are non-calculator and 15 multiple choice that are calculator. So a total of 45, which I feel like is a good number. No, you said multiple choice. Free response, there are 6. There's 2 that are calculator and 4 that are non-calculator. Which again, I think is an appropriate number. It's long, but you don't want there to only be 1, you know what I mean? You want there to be enough so it's a lot of points. All right. Okay, back to what is at hand here. Now you have to raise the power, so it's going to become less negative. It'll be y to the negative third, and then what would you put in front of that? Yeah, negative 1/3, good. And I'm going to fix that in the next step. Equals, what would this give you? Yep, 2x squared plus c. Now I would take a step, and if you're writing with pencil, you can just erase it. I'm going to rewrite it. Fix the negative exponent. You can rewrite this as negative 1 over 3y cubed. Do you see how I brought the negative back down to the denominator? Do that. Like, just take a step and do that. If you don't want to write the whole thing a second time, you can just erase it and fix it or scribble it out, whatever. But go and fix that, because when you go plug this in, it'll be a lot easier. We're going to plug in 0 for x, negative 1 for y. So if x is 0, what do we have on this side? Like, literally just c. It's nice if it's 0, but it isn't always. And if you plug in negative 1 for y, yeah, good. It'll be positive 1/3 because those negatives are going to cancel. So you're going to go back to this step. You don't have to draw an arrow. I just do that sometimes to go, hey, like, this is the step you're going back to. You're going to recopy it literally exactly like it looks, but instead of c, you're going to put 1/3. Now, the rest of this is algebra. I'm going to have to come over here because I ran out of space. Can you watch me point to this? Here's the easiest way to do that. Mathematically, you would multiply this y squared over here. Oh, it should be cubed. Thank you. That is called a what, guys? May happen to everyone. I'm sorry. Thank you. Crisis averted. Everybody does. That means I'm a normal person. Well, I don't know if I'm normal, but, like, you know what I mean? Happens to everybody. Okay, watch me point to this. You would take the y cubed and multiply it over here. And then you would take all of this stuff and divide it over here. Those things are just going to switch places. Are you following me then? Take the y cubed and multiply it over here. Algebra is just moving things. You're going to move this over here and move all that over there. So it's going to be negative 1 over 3 times all that equals y cubed. I just multiplied the y cubed to the right side and divided all of that back to the left side. Again, if it looks like a complete mess, you probably did it right. That's how these look. Oh, good. And then you would cube root, which the easiest way to do that is like that. That's your answer. You don't worry about plus and minus if it's an odd root. That's only for the even ones. Okay. All right, what do you notice about this one? Something should jump out at you like, hey, hold on a second. Yeah, there's no y's. It's all x's. So that means the only thing you need to do to separate it is to multiply the dx over. Now, here's my suggestion. I would put a 1 in front of the dy. If you're like, nah, I don't want to, that's fine. It is, personal preference. But I've been doing this a long time, and I've found that if you don't put the 1 there, people forget what's going on. So I would just put a 1 there. All right, antiderivative. Kind of nice when it's just 1 on this side, because what's your antiderivative of 1? It's just y. That means you will not have to do any algebra at the end because y is already by itself. Isn't that nice? That's cool. Now this side is a little messier, and I feel like if I wait long enough, someone will come up with it, because there is a different method for how you get through that. You can't just write the answer. It's use substitution. U would equal what? Good. Du would be, it'd be 3x squared. Good, dx. And then you have to turn a 3 into a 5. You can, it just involves a fraction. It would be 5/3 du equals 5x squared. I ran out of room to put the dx. Anyway, there's going to be a 5/3 out front. So it's going to be 5/3 integral, leave a space, du. What's still there? Good, 1 over u. What's your antiderivative of 1 over u? It is good, and you need absolute value. And what was u? U was Good, perfect. And then at the end, to cap it all off. And that's actually your answer, and we're done because y is already alone and there was not what? All right, cool. I'm gonna try and get through 6 and 7. I'll stop it there. I'll have to do 2 videos. That's tomorrow. Oh, and this one's gonna be real quick. Do you see how there's only an x? So the only thing you have to do to separate it is multiply over the dx. So this one's another nice one because it's going to end up being y equals. Now, this would also be a u substitution, but I want to try and coach you to go through it without writing it. This one was messy. I would write that out, okay? This one is not messy, and the exam is timed. So listen, what would you let u equal? I'm not going to write it, but what would you let u equal? What's the adjustment number? What? Just slap a 1/5 in front and be done with it, okay? So you're going to have y equals 1/5. What's the antiderivative of cosine? We already did this one. Good. So sine 5x, and then at the end, let's see. No, it's not. And I actually recommend you don't write it out. Be as lazy as possible to get the right answer. Okay. Now this one, I wrote it this way because I've seen them do this before. It's really annoying. What does y prime mean? That's dy dx. You need it written as dy dx though if you want to separate the y and the x. So think of this as dy dx. What we're going to do is divide this square root to the other side. So you would have dy dx equals x over that square root. And then, yeah, now it looks a little bit more normal. Now, how would you separate that? Yeah, and yeah, just move over the dx. So I'm actually, I just erased that, so I didn't have to write it all over again. So what's nice about this one? Oh, what is nice about this one? What makes us happy about this one? It'll be y equal. Like you won't have to do algebra at the end. You'll just be done because y is already by itself. Now, this is not nice. This is going to be a u substitution. What would you let u equal? Good. And then that derivative is 2x dx. And then what adjustment number do you need? Perfect. So I would write it out if it's more complicated. If all you do is see a 5x there, just slap a 1/5 in front of it and be done, all right? But this is going to be 1/2 out front, du at the end. What's still there? Yeah, it would be 1 over square root of u. You are correct. I would write that as u to the what? Close. Negative 1/2. Good, perfect. Good. Nice job, guys. That was really hard. You guys got that. Why is it negative? The denominator. Good. Why is it 1/2? Perfect. All right. So y equals 1/2 times. All right, now we have to do the antiderivative. Good news, though. You're going to add 1 to that. So negative 1/2 plus 1 is positive 1/2. So we made it positive. That's good. And then what would you need in front of that? A 2. Oh, and then at the end, perfect. What's another good thing that's going to happen there? Yeah, those cancel.
I apologize. That was.
All right. What was u? 3 plus x squared. So, and 1/2 means square root. I would just go ahead and write it as square root 3 plus x squared plus c. Now we aren't done. We would be, except what? You have an initial condition, so you have to figure out what c actually is. We're going to get one particular answer instead of an infinite number of answers. Yeah, but it's just one, and usually it's not a difficult one. All right, but it's not 0. Good noticing. So if you plug in 1 for x, what do you get out of this? Square root of 4, which is 2 plus c, and then y was 14, so c is 12. And then you're going to go back to this step right here. Just copy it exactly, except put a 12 for c. And you're actually done because it's already y equals. You don't have to do any more algebra.